Looking at this integral, there's a few different ways to do it. Probably the most straightforward was to let u equal cosine of theta. So then du would be minus sine of theta times d theta. So if I solve for d theta, I get du divided by minus sine of theta. Right? So I replace d theta in terms of du, and then I have the integral. In this case, we want to change the u bounds, right? U would be cosine of 0, and this u would be cosine of pi over 4. So then I'll go ahead and write this sine of theta. D theta would be du divided by minus sine of theta. So the sine of thetas cancel, and then I get u cubed in the denominator. So cleaning this up a little bit, cosine of 0 would be 1. And cosine of pi over 4 would be square root of 2 over 2. U to the minus 3 du. This is just simply the power rule. So this would be u to the minus 2 divided by minus 2. Oh, I lost this negative here, so that goes there. And then I'm integrating from 1 to square root of 2 over 2. So I have really 1 over 2 u squared, just to kind of clean up my negatives, what's going on here. So if I pull out the 1/2, I'm getting, if I plug in the upper bound, I would have 2 over 2 minus, plug that in, 1 over square root of 2 over 2 quantity squared minus, I plug in the lower bound of 1, I get minus 1. Remember, I pulled the 1/2 out front. So what do I have here? This would end up being 4 over 2 minus 1. So that would be 1/2, 2 minus 1, which would just be 1/2. The algebra this way is a little ugly. Another way we could go about it, and this would make the algebra a little nicer, is to turn in, I would write sine of theta over cosine of theta times 1 over cosine squared theta. And then I could write that as tangent of theta times secant squared theta d theta. This just goes a little faster with my u substitution. If I let u equal tangent of theta, then du would be secant squared theta d theta. Turns out secant squared theta d theta is right there, tangent's right there, so if I let u would equal tangent of 0, to u to be tangent of pi over 4, tangent of pi over 4 is 1, and then I would have u du. So I'd integrate tangent of 0 is 0 to 1 of u du, which would be u squared over 2, which would be 1/2 minus 0, which is 1/2. The algebra is a lot nicer this way, but you still get the same answer doing the u substitution as cosine of theta. So trig problems can be a little easier if you just tweak it a little bit, but you still should be able to get the right answer here. You want to make sure that you change your bounds anytime that you do a u sub, that you change the right bounds, or once you integrate in terms of u, you put it back in terms of theta and use, these are theta's bounds. So if you do a u substitution, you need to change your bounds in terms of what you're substituting it in terms of.